Hi ladies and gentlemen, this is Mr. Green. This is another in my lessons on Algebra 2. We are approaching the end of the semester, and so complete Unit 7. We're working on Unit 8 stuff. We got to get this stuff done. We'll be taking the test after we get back from break, but for Unit 8. But then we're also going to be into the final exam. So you got to be ready for this stuff. So what are we looking at today? Today we're looking at 8.04. We're going to solve some quadratic equations. We're going to solve them using completing the square. We're going to solve them by using the quadratic formula, and then we're going to talk about a thing called the discriminant to help classify the number and types of solutions that we could be looking at. Okay, so we're going to be looking at that as well. So when we talk about completing the square, the one thing you have to remember is b over 2. That's the one that you always need to remember. Okay? If you think about the general equation, you've got ax squared plus bx, you got ax squared plus bx equal plus c. Okay? And that b is the number that's in front of the x. Okay? So what you have to do is you have to try to isolate those x's by themselves. So you get this as x squared minus 2x equals negative 5. In this particular situation, b now equals a negative 2. So b over 2, when I divide by 2 in this situation, I'm going to get that b over 2 is equal to a negative 1. That's an important number. Don't lose that one. We also need to have b over 2 squared. So negative 1 squared, okay? So negative 1 squared is equal to 1. That's what I'm going to add to both sides. Why am I doing this? I'm going to show you right here. 2x plus 1. That 1 is what the b over 2 squared is. And I'm going to add that to the other side too. Negative 5 plus 1. What do I get when I do this? I get a perfect square on this side. X minus 1. Where'd that minus 1 come from? The negative 2 over 2, that negative 1 right here. That number is what goes right in there. X minus 1 squared is equal to negative 4. Now I can write this in vertex form, and I'm going to get that x minus 1 quantity squared is equal minus 4 equals 0, or y. That's vertex form. That was easy to do. But they were wanting me to solve this, right? So to solve this, I've got the value x minus 1 squared equals negative 4. I can take the square root of both sides of this equation. I get x minus 1 is equal to the square root of negative 4. Up, negative under a square root symbol. I'm going to have a complex answer here. So I'm going to add 1 to both sides, and I'm going to get that x is equal to 1 plus 2i, plus or minus 2i, plus or minus, because I always have to have 2 of those. That would be my solution that I would be looking for here. Okay? Now, I don't think this is a big jump here. The square root of 4 is 2. The square root of negative 1 is the I. The plus or minus comes down. I'm adding 1 to both sides. So that would be my solution that I'd be looking for. Okay? Okay. This one, I've got to isolate the x's. What I'm going to do is I'm going to add 2x squared to both sides. Why? Because that put the x's on the same side. Plus 9x equals 56. I'm going to divide out a 2 because I've got a 2 here in the front. I want to get rid of that. Okay? So I'm going to divide by 2. And I'm going to get that x squared plus 4.5x equals 28. Okay? Well, I can complete the square. How can I complete the square? I'm going to take 4.5 over 2, right? And that's going to be equal to 2.25. Okay? And I'm going to square that. 2.25 squared. And I don't have it right in front of me, so I'm pulling up my calculator. 2.25 squared gives me 5.0625. Okay? So that's what I'm going to be adding to both sides of the equation. And this is what my solution is going to have, my square is going to have in it. So here I go. X plus 2.25 squared plus 5.0625 equals 28 plus 5.0625. Oops, sorry, that wouldn't be there because I already added it to this side of the equation. Okay, so let's take 28 plus 5.0625 and I get 33,625. So I've got, bringing my work up here at the top, I've got x plus 2.25 squared is equal to 33.0625. Take the square root of both sides. So I'm going to have x plus 2.25 is equal to plus or minus square root 33.0625. Subtracting that, I get x is equal to minus 2.25 plus or minus square root 33.0625. Okay? What this is actually equal to, the 0.0625 is 1/16. So I might say that x is equal to negative 2 1/4 plus or minus the square root of 34 over 16. Okay? Yeah. X is equal to 2 1/4 plus or minus 1/4 times the square root of 34. That's probably how I would leave it. It's my final answer. I keep working sometimes because I don't get to the answer that I think I want to get. Okay? That just looks like it'd be the simplest form right there. But any one of these would have worked as an answer from here down. Okay? So let's look at another one. Let's go on and look at the quadratic formula. The quadratic formula is one that you just have to memorize. If you've got ax squared plus bx plus c is equal to 0, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This formula right here is one that you just got to memorize because you're going to use it. Anytime you got quadratics, that is your final approach. First thing you're going to try to do is to factor it. Second thing you're going to try to do after you've tried to factor the equation is you're going to try to do completion of the square. After you've tried to completion of the square, the next thing you can do is quadratic formula. Interesting thing, see how you got the square root here? That square root, everything in there is what they call the discriminant. Okay, see right here, discriminant. This is b squared minus 4ac. If that discriminant is a positive number, you're going to have two real roots. If that discriminant is equal to 0, you've only got one real root. And if it's a negative number, you've got two complex roots. Okay? So what is this meaning? If your discriminant is equal to 0, your quadratic is just touching the line. And there are two solutions right there. Actually one, but it's two solutions. If your quadratic is a positive number, you've got two solutions right there. If your if your discriminant is a negative number, your quadratic never touches the x-axis. So you've got a complex root. That's what you're looking at. 1, 2, or none. Okay? And it depends upon that discriminant. So they're going to give us some problems here. If you look at this, write down, first thing, A equals 3. B equals negative 12. C equals 6. So let's use the quadratic formula in this situation. X is equal to negative 12. That's negative B. Plus or minus the square root. Well, B squared. Negative 12 squared. Minus 4 times A times C divided by 2 times A. Okay? So let's go through here and now clean this up just a little bit. I just wrote down the numbers as I was going there. So I got a 12, negative of a negative, plus or minus the square root. Negative 12 squared is 144, minus 4 times 3 is 12, times 6 is 72, divided by 6. Well, 144 minus 72 is 72. So this is going to be, that's a positive number. That means I'm going to have some real solutions here. 12 plus or minus square root of 72 divided by 6. 72 is 36 times 2. So what I'm going to do is actually factor that a little bit, and I get 12 plus or minus 6 square roots of 2 divided by 6. 6 goes into 12 2 times. 6 goes into 6 one time. So what am I left with? 2 plus or minus the square root of 2. That would be my two solutions that I was looking for. This plus or minus actually gives you two different numbers, two different real numbers. And that would be my solution that I would be looking for. Okay? Let's use this one with the quadratic formula. So the first thing I've got to do is get it into standard form. So 2x squared plus 5x plus 7 equals 0. Standard form. A equals 2. B equals 5. C equals 7. Writing the quadratic equation. X equals negative B 5 plus or minus square root 5 squared 25 minus 4 times 2 times 7 divided by 4, which is equal to negative 5 plus or minus. Well, 4 times 2 is 8. 8 times 7 is 56. So I've got the square root of 25 minus 56 divided by 4. Well, 25 minus 56 is going to give me a negative number. So I'm going to get a minus 5 plus or minus negative, or square root of negative, let's see here, 25 and 6 is 31, negative 31 divided by 4. Well, negative 31, not going to be able to get anything out of that. So I'm going to get a negative 5 plus or minus I times the square root of 31 divided by 4. That would be my two complex solutions to this problem. And I'm sorry about writing at an angle. You can tell I'm dyslexic and angles work for me. Okay. This one is simply asking me to use the discriminant to classify the number and types of solutions. So in this particular situation, all I got to do is make certain I write down A equals 3, B equals -1, C equals 5, and then B squared minus 4AC. So B squared is -1 minus, -1 squared minus 4 times 3 times 5. 15 times 4 is 60, so I've got 1 minus 60, that's negative. So I have 2 complex, COMPLEX, solutions. Okay? Looking at this equation, 6x squared minus 7x plus 2 equals 0. A equals 6, B equals -7, C equals 2. Discriminant, B squared -7 squared minus 4 times 6 times 2. 12 times 2 is 48, so I'm going to get a 49 minus 48. I get a 1. Guess what? There are 2 real solutions. That's all you have to do to find these with the discriminant. Okay? Okay, moving forward. I appreciate you letting me know that what course you're in, that you're in Algebra 2. It really does help me locate your information quicker and give you answers. I appreciate it, and I will see you next class period.